Hey guys, and welcome to the school station. Today's video I'm going to be talking about atoms into ions. This is from the AQA GCSE Chemistry 91 paper from the unit Atoms, Bonding and Moles. In today's video I'm going to be talking about atoms into ions and how elements actually have to be stable in order to be able to react properly with metals and non-metals. So I hope you guys enjoy this video, and let's just get right into the video. So before we actually get into the main lesson of today, I actually just wanted to recap about something we've learned in our previous videos. In my electronic structure video, I talked about the maximum amount of electrons in each shell. So we've obviously learned that when we actually have there is actually a limit of each shell. For example, in the first shell, after we actually have 2 electrons filled up on the first shell, we have to go straight to the second shell. After the second shell has 8 electrons, we have to go straight to the third shell. And it keeps on going like that. We have to know that for the first shell, if we have 3 electrons, like for example in helium, we have in lithium we have 3 electrons, we basically have to know that after we have filled up the first shell with 2 electrons, we can't just add 1 more electron to the first shell. We have to go straight to the second shell because the first shell can only hold up to 2 electrons. Therefore, it's really important to memorize this table and know that the maximum amount of electrons in each shell, because they're really important to understand today's lesson. So now that we've understood about the maximum amount of electrons in each shell, now we can actually talk about the special group in the periodic table. This is the noble gases group. The reason why noble gases are very important and very special in the periodic table is because they have the full amount of electrons in the outer shell. So, for example, if you guys can see in this example, we have helium. Helium is the first element in the noble gases group. Helium has only 2 electrons, but this still makes it have the full amount of electrons in the outer shell, because as you guys can see on the first shell, it can only hold up to 2 electrons, so it already has filled up its limit. So therefore, helium has the full amount of electrons in the outer shell, which is the first shell. As we keep going down the group, you will always realize that they always have the full number of electrons in the outer shell, and this makes the atoms non-reactive and stable. This is what really makes this noble gases group special, because they're already stable and they don't have to necessarily share electrons or, transfer electrons, as we will be talking about later on in the video. However, if you realized, all these other elements in this periodic table do not have a stable arrangement of electrons, because they always have some electrons left over. For example, in let's say group 3, you will see that they always have 3 electrons in the outer shell, and they still have some space for more electrons to be filled in. So now we actually have to talk about reactions. So as I said, most atoms do not have a stable arrangement of electrons because they do not have the full number of electrons in the outer shell. When atoms react, they take part in changes which give them that stable arrangement of electrons. They may do this by either sharing electrons, which is called covalent bonding, or transferring electrons, which is called ionic bonding. So these are the 2 main ways of allowing atoms to actually get a stable arrangement of electrons, to allow electrons to be filled up in the outer shell. So this is what we're actually going to be talking about very specifically, and this is why I'm going to be making 2 separate videos, one about covalent bonding and one about ionic bonding, because this is super important for you guys to understand and be able to know how elements actually get the full number of electrons in the outer shell. So now we actually have clarified about electrons and how they, in the outer shell, if they're full, they actually get a stable arrangement. Now we have to talk about what is an ion. So the title of this video is Atoms into Ions, because we actually have to understand first what is an ion. An ion is an atom that has lost or gained electrons. If an atom loses electrons, it has a positive charge. If an atom gains electrons, it has a negative charge. So what I'm trying to say over here is that any atom that loses or gains electron has an ion, and they will either have a positive charge or a negative charge. So this is basically what we're going to be looking at in ionic bonding, okay? So the way I like to remember this, if an atom loses electrons, it has a positive charge, is by just kind of remembering that when you're giving something to, let's say, charity, you're doing a good thing and that is positive. And if an atom gains electrons, if you're taking stuff away from people for no reason or without permission, it's negative, it's a bad thing. So if an atom loses electrons, if you give to charity, it is positive, so you have a positive charge. And if you actually take something away from people, it is negative, so it has a negative charge. So that's how I like to remember this, and this is really, really useful in ionic bonding and covalent bonding. So I definitely recommend you guys to try to understand this these two sentences because it's really, really important. Now we're going to be talking about why do ions and ionic compounds form. So as I said, atoms gain or lose electrons to get a full outer shell or become stable. So as I said earlier, ionic bonding and covalent bonding are the two main ways for elements to actually become stable, because becoming stable is a really important thing. So atoms gain or lose electrons to get a full outer shell and become stable. And ionic compounds are held together by ionic bonding. Ionic bonding are basically a very strong force of attraction between oppositely charged particles. And that's basically how ionic bonding holds together ionic compounds, which is what we're going to be talking about again more specifically in our ionic bonding video. So how do you know if an atom will gain or lose electrons? So atoms will gain electrons if their outer shell is mostly full, and atoms will lose electrons if the outer shell is mostly empty. You may not be understanding this right now, but when we're going to be going on to the examples and even our ionic bonding video, you will definitely understand more about this. So as I said, when you basically gain electrons, it is a negative thing, and when you lose electrons, you're giving away, so it is a positive thing. So you'll get a positive charge. So the way we actually understand whether atoms will gain or lose electrons is basically by just looking at the periodic table. So over here we have the periodic table, and we actually have the electronic configurations for each of the first 20 elements. So if we look at this clearly, we can see that, for example, in beryllium, we have the electronic configuration of 2,2. So as we can see that the second shell can only hold up to 8 electrons, and as you guys can see, beryllium has 6 more electrons until it fills up its outer shell. This means that it's a very long time for its outer shell to become full. And if it reacted with an atom like, let's say, fluorine, which has 7 electrons in the outer shell already, and if they only get 1 more electron, it will become stable. Obviously, beryllium will have to give their atoms to fluorine, because fluorine is nearly full, so obviously it will be more benefit if beryllium gives the atom to fluorine rather than fluorine give all of its atoms to beryllium, because obviously beryllium has 2 atoms, and if it loses those 2 atoms, it will become a full outer shell. But fluorine, if they loses 7 atoms, it's not very helpful, so beryllium will give to fluorine because fluorine already has 7 atoms in the outer shell, and if beryllium gives 1 more atom, fluorine will become a full outer shell and will become stable. So that's what we really have to understand, that atoms will gain electrons if the outer shell is mostly full, and because it's really easy for it to just become full, and atoms will lose electrons if the outer shell is mostly empty. For example, beryllium, it still needs 6 more electrons to become full. Now we're going to be talking about ionic charge. So as we already know, that basically if we look at this, we can see this trend. So obviously, we know that, for example, in group 1, we've already clarified that all the electrons in the outer shell of group 1 always has 1 electron. For group 2, we can see that the atoms actually have 2 electrons in the outer shell. For group 3, we can see that there are 3 electrons in the outer shell. For group 4, we can see that there are 4 electrons in the outer shell. If we keep on carrying like this, we can see that the number of the group corresponds with the number of the atoms in the outer shell. So the ionic charge is exactly the same. For group 1, the ionic charge is going to be +1, because if we look at over here, we can actually just give 1 atom away to another of these elements from the other groups, and we will get a full outer shell. For example, lithium, if you just give one more atom away, it'll become a full outer shell. Instead of like getting 7 more atoms for it to become a full outer shell, lithium can just give one more atom away. So basically, we just have to really understand that for group 1, if they give one more electron away, it is more useful. For group 2 is +2, and if we skip this, if we go to group 3, it's +3, -3, -2, -1, and 0, because noble gases already are stable, so they don't have to react with any non-metals. So we just have to really memorize this ionic charge and just correspond to the group numbers, but obviously when it gets to over here, so 5, 6, 7, we can obviously see that it's going to be -3, -2, because then you're starting to gain electrons. Just quickly before we end this video, I just want to talk about forming ionic compounds. So we're going to be looking at dot and cross diagrams in the ionic bonding video, but this is just how you would represent it without dot and cross diagrams. So if there was a reaction between calcium and fluorine, if we go back to our periodic table, we can see that calcium is all the way over to this side, so it's 2, 8, 8, 2, so there's 2 electrons. There's still many more electrons for it to become full. And also we can see that fluorine, it has already about 7, it has 7 electrons in the outer shell. So basically, if we just give two away to fluorine for it to become a full outer shell, and if you just basically just minus that away from calcium, we can get CaF2. So basically just swap the charges of each of them, and this is what we're gonna. So the 2+ gets given to F, and the F-, the -1 and 1 is the same thing. So it would be Ca with an invisible one. So it's going to be CaF2. So I hope you guys have enjoyed this video, and I hope that you guys understood. So just as an overview of what we have learned today, we have learned the 2 types of bonding that can happen between atoms in groups 1 to 7. We've also understood that noble gases are stable due to the arrangement of electrons. We've learned the ionic charge of the different groups, and last of all, we've also learned how to form ionic compounds. Hope you guys enjoyed this video. Give this video a thumbs up if this helped, and subscribe to the School Station for more free science and maths lessons. Bye guys!